Awesome. Hi, everyone. I'm Luke. I'm a senior bioinformatics engineer at Genomics England, and it's actually great to be here wrapping up the second day of this conference, speaking about how we're migrating to Nextflow. I'm joined by my colleagues, Ricardo and Błażej. So I'll be going through a bit of an introduction about our organization, then we'll speak about our unique migration strategy and refactoring work that we're planning after that. We'll be speaking about how we're validating everything we're doing, and then we'll be sharing lessons learned with everyone. Hopefully you get to learn a little bit from our experience as well. So our organization is Genomics England. We were set up in 2012 in England, primarily to deliver quite an ambitious project, which was to sequence 100,000 genomes. The aim for this was to kickstart the genomic medicine revolution in the UK. We actually succeeded in delivering this in 2018, and thanks to our success in doing that, the UK government decided to start offering this as a routine service through the National Health Service. Now we have a new project that we're hoping to start off, known as the Generation Study, and we'll be scaling up to support this, and this is part of the reason why we're moving to Nextflow. So briefly about the organization, we're split into two different tribes. There's the clinical tribe, which we fall under. We are fully accredited, and our bioinformatics pipeline is a medical device. When patients need a genetic test, their data is sequenced by Illumina. Then it is sent to us, where it's passed through our analysis pipeline. Findings are returned to a clinician, and with their consent, their data is added to a trusted research environment where further insights might be gleaned by researchers who gain access after being vetted. And essentially, if any further analysis is discovered, that further knowledge is added to our diagnostics to help future patients when their data hit our system. So we fall under the clinical part of the organization. So we're migrating to Nextflow primarily because our current system, known as Bertha, while it served us well, it was hyper-optimized for the 100,000 genomes project, and would like to start supporting new use cases. In addition, workflow management development, solutions development is not our core business offering, so we don't really want to do this anymore. And leave it up to the next engineers. We'd also like to start supporting a wider range of compute environments, because right now we're running primarily on our on-prem infrastructure, and we'd like to start using public clouds such as AWS. And this would support our ambition of, for example, completing the Generation Study, where we are aiming to sample 100,000 samples of newly born children across England. So this is the project which we are working towards to replace our current bioinformatics workflow engine. It's a combination of Nextflow and Nextflow Tower, and uses AWS functionality for automation. We call it Genie. And with that, I'd like to pass to my colleague Błażej to speak to us about the migration strategy.
Thank you, Luke. My name is Błażej Szczerba. I am software engineer at Ardigen, and we are working with Genomics England for over a year in this project. And this is how current sample journey looks in Genomics England clinical services. So at the end and at the beginning of the journey, there's a patient. Then there's a whole genome sequencing of patient sample. Then the sample is ingested in our system, and our in-house workflow manager, Bertha orchestrator, starts 3 workflows. And this workflows is a set of bioinformatics modules. At the end, the result is dispatched back to the clinician and then the patient. It is worth to mention that Bertha is a critical medical device, and this is really important when we're looking at the priorities that we had in the project. So our first priority is to get out of Bertha as quick as possible, but we need to think about minimize the risk and minimize divergence between old pipeline, old workflow manager and new one, because this migration should be transparent for patients. And the last priority for us was to work in small iterations to validate if our migration is going well and to again, minimize risk. So, at the last summer, we wanted to explore 3 strategies. We wanted to see how we're going to do that. So the first strategy was to full refactor to Nextflow. In this strategy, we rewrite from the ground up the workflows that are written in Bertha, and we're going to leverage all Nextflow features. However, this strategy comes with great risk of divergence because Bertha is still in active development, and the overhead updating during the migration is not acceptable. The second strategy was strategy lift and shift. So as Bertha is Bertha Compute, the set of bioinformatics modules that is used in Bertha, this is used in on-premise infrastructure at Genomics England as singularity image. We can leverage that and use this image, this container, right away in Nextflow. So this comes with low risk of rally. So we know that the same code works exactly in Bertha and Nextflow, and it also looks as the quickest strategy. The first strategy that we had in mind is to extract gel libraries from Bertha Compute. So Bertha Compute is a monolithic software. It's a Python package included in a singularity image. And in this strategy, we wanted to separate that to the smaller packages and import it back to Bertha and Nextflow. So the risk of divergence is still low. We have really nice architecture because we can actually use any workflow manager that we want, but still the time to do this intermediate step is a really important factor. So we decided to go with lift and shift strategy. So we're going to use the singularity image with Bertha Compute code unchanged in Genie. It is highly conservative. As a next step, we're going to deprecate the orchestration, the Bertha orchestration part of Bertha system. And then we're going to refactor our pipelines that are already orchestrated by Nextflow to leverage all Nextflow features. So this slide you've already seen, and this is our proposed solution. So actually, we want to replace Bertha orchestration with Nextflow and Nextflow Tower and automate this with AWS. So one of the challenges that we faced during this migration is to assure that Nextflow and Bertha Compute code has a common interface. To do that, we created an adapter over the Bertha Compute that basically translate the execution parameters from Nextflow to meet Bertha Compute modules requirements. It also communicates with some external APIs. This functionality was before included in Bertha Orchestrator, and now it's a part of our wrapper. So this is exemplary code that we had right now in Nextflow. It's really easy. So this is just calling a Python library. As you can see, there's no bioinformatics code here right now. This will be the part of the next step. So we see that we are using the same code that are used in Bertha. We just call Bertha from Nextflow. So the migration status for now, we migrated 2 clinical programs, rare disease, and we created a generation study program. This includes 5 migrated workflows and over 60 components from Bertha that are now executed in Nextflow as Nextflow processes. And that was my last slide, and I give back voice to Luke about the refactoring strategy. Thank you.
Thanks, Błażej. So as Błażej described, we're migrating in phases, and this is a later stage where we will be refactoring our migration once we've exited Bertha Orchestrator. The initial version of workflows when we migrate is going to be optimized for minimizing divergence and minimizing risk, but less for taking advantage of everything that Nextflow has to offer. In addition, we're going to have 3 distinct workflows per sample to run, just like Bertha used to have it. And actually, we had to create another overarching workflow to link these 3 workflows. We're calling it the conductor workflow, which runs before and in between each of the other workflows to get them going. The modules that we've moved over from Bertha contain a mixture of bioinformatics logic and API calls, which can make them brittle to run, which is not great for us because we need the highest reliability, given that we need to return data to our doctors in a very short time. And another disadvantage to how we migrate it is the fact that we're not using channels actually for our file handling at the moment. We're still using file handling that used to be used in the previous system, which is basically written in Python and contains things like direct OS file calls, which makes it difficult to run on things like S3, for example, using S3 as a storage layer. So we have 2 horizons of delivery, which will be following to future-proof our workflows. I'll be running through some of the ideas we're going to pursue. The first is to split up this big singularity image into multiple images, 1 per team working on bioinformatics code, just to allow them to work independently and in parallel. We'll be doing an audit of the module logic to see if there's any legacy logic which has built up over the years and isn't needed anymore. We'll be switching over to using channels, which will make it much easier to use S3 as a storage layer, which we're quite keen to do. We'll also be following NF core best practices when it comes to separation of concerns in our modules, such as separating API calls from bioinformatics logic and making sure a module does only one thing. And we'd also love to use as much of NF core standards as possible. That includes the way modules are shared and documentation as well, because I think there's a lot of great examples there that we can emulate. As a second horizon of delivery, we'd like to create adapters for third-party services that might be getting swapped out to make it easier for us to do that. We'd also like to explore merging the 3 workflows into one to make orchestration simpler. We'd like to profile our code to see if there's any room for improvement. And finally, we'd like to look through the code, which might have implicit dependencies, and actually expose all of that as parameters, basically to make them more portable, to be able to place them anywhere in the workflow without any issues. And I guess with all of that, this is quite complex work, and since we're dealing with patients' data, a key part of our process is validation and making sure everything works as it should. And with that, I'll pass to Ricardo, who will speak to us about Jasmine, which is a custom automation testing framework that we created to assist us.
Hi, I'm Ricardo, and thanks, Luke, and as Luke said, I'm going to talk about how we are validating our migration. So we have a system that we're calling it internally Jasmine, and it's our testing environment. And the reason for this to exist is because we have very, very complex dependencies that may include hardware, the architecture where we're running. Software, we have to keep a good track of which version of each software we have, because as it was mentioned before, it's accredited as a medical device, so we need to be very precise with that. And there are also interactions with humans. So there may be problems with the sequencing. It may be that we detect that the samples don't correspond to the family. So. Or there was a mislabeling. So all these kind of interactions require to be processed by someone. So that decision needs to be made if there is a deviation on the pipeline. So for that, we use external systems like Jira. So this is just a selection of some of the systems that we have to interact with. So how do we make sure that all these interactions happen correctly? So we have a Docker Compose. We use Docker Compose to coordinate several images that correspond to our workflows initially, and also to these third-party systems. And the idea here is that we want to be able to run the pipeline and connect to all these external services locally in our development environment and in continuous integration. That way, we avoid having to go and test with full samples. I'll talk about that a little bit later. But one of the things that we found out, we thought like, oh, how hard can it be to set up all this to run locally? Well, it ended up most of the year. Now we are in a good position where we can test things quite efficiently, and we are already finding bugs quite quickly. But yeah, it took a little bit longer than we expected because there were actually more services than we initially thought. But that's fine. Right now it's mostly done, and that's a good thing. But the other thing that we have, it's because this is an accredited pipeline, we have a set of sentinel samples that we know that we need to find some mutations, or we need to find some variations that are related to certain clinical results. And this set of tests take them anywhere between 2 and 3 days to run and to be analyzed to make sure that they work properly. And we have a quality assurance team that keeps, every time we do a release, they go and test that things are still working as expected, and if there are changes, that they are also reflected on these samples. However, we are migrating the pipeline. We cannot afford a test time of 2 or 3 days just to figure out that on the 20th component we had a typo, right? We need faster testing. So for that, we created a smaller sample. So we have a fake genome where we caught the first 100,000 bases of the human reference and created an annotation, and in some cases also included variants in this region that we can test just to make sure that the components go through it. We kept the X and Y chromosomes because some of the validations are related to the sex of the patient. And for that, you need a full chromosome. So anyway, that allows us to go from 2 or 3 days to run the pipeline with the real samples to having a continuous integration that can take 15 minutes. Also, we can run it. It takes a few minutes on our development environment. I mean, it's not instant, but still it's way better than having to wait a day to find some errors. So we move from developing directly on the cluster to developing completely locally. The other thing that we have to do to speed up or to be able to make the migration, it's to simplify how we look at the workflow. If we look at the full workflow, it looks quite complicated. I mean, it's roughly linear, but still there are several modules that have to be tested. So instead of trying to test everything in one go and trying to understand everything, we simplified the workflow and we divided in the natural checkpoints that it already has. And then the workflow at the big scale, it becomes quite linear. So you can see that the actual workflow, it's just one step after the other. However, when we look at the detail, we use the ability of using workflows as modules in Nextflow. So that way we can abstract some of the complexity. In this case, this section has three concurrent processes, and then the actual Nextflow code, it looks a little bit more complicated than just having a linear sample, but it's a linear workflow, but it's still a complexity that you have the diagram and you can read the code and you can see that it matches. I mean, it's not trivial, but it's not that difficult. And then in order to test and to make sure that every part of the workflow works, we have this idea of subsections where we only test the linear parts of each one of the workflows. So in this case, we run a test of just two components on the example, and we run the prerequisites. We assume that the upstream part of the pipeline is already working, so we are migrating from the top to the bottom, and we assume that works, and we can make sure that this subsection is still working. And every time we make a change, we run continuous integration to make sure that whatever change we made doesn't break something that we already know that works. And that has helped us to keep a little bit sane. So as we mentioned, we have our workflows are accredited as a medical device. So that means that if something changes, we need to report it. We need to make sure that everything is exactly the same all the time. So in order to test the new workflow, we need some sort of ground truth. The ground truth is running the old workflow and having the same results. And the same results is not only the files, it's also all the side effects. So as I mentioned, we have these external databases that report to our users and to our providers. We also keep track of all the files that we generate for audit reasons. So if somebody comes and asks why we have these results, we can go and check every single file and make sure that everything runs correctly as expected. So we need to make sure that our new workflow still is consistent with these requirements. So we save the state of the database and this Docker, not only a database, but all the databases and all the files in the Docker Compose set of images, and we run it twice, once with the old workflow and once with the new. And then we check that everything is exactly the same. Of course, it's not trivial. Some files have timestamps, so of course that's not going to be the same, but we have comparators. So that way we can make sure that our system is still the same. Just as a reminder, we are just changing the workflow manager. We're going to change the pipelines in a later stage or the modules, but that's not the aim right now. And for new workflows and for cases where when we have already depreciated Bertha, we can also make a fake state of or unexpected state of the outputs. And see that on what we use right now to compare, we can also use it to feed a known state or an expected state. And that way we can also validate that things are working correctly. So finally, I want to talk a little bit of the lessons that we learned over the last year. Many of them are like some things that we have to question ourselves. So one of them is how can we make sure that whatever we are running, it's always correct. And one of the problems that we had before is that whenever we updated the pipelines, we couldn't be completely sure that it was the same. So right now, every time we have a release, we have a singularity image that has the exact versions of all the software, so we can tell this sample was run with this version, and this is what we expect. So this is mostly because the workflows are still evolving. So we are a provider for the health system in the UK. So whenever they detect something that they need, we need to update. So this is a moving target. So this helps to keep our systems consistent. For the same reason that the workflows are changing and the expectations are changing all the time, we cannot just shut down everything, refactor everything, and start over. So we need to keep the system working all the time. So for that reason, we are using an iterative model where we are just changing one piece of the system at a time. Eventually, we hope to have a linear system, a more efficient system. But right now, we need to take this approach because we cannot afford to stop. Another thing is, as part of the migration process, we are probably not interested on every single line of code in our team. Of course, there are teams that are working on each one of the modules and all the details, but we don't need to understand all this as part of the migration effort. So we use black box testing. So this testing framework, once you run it, you know what happened. If there is some error, if we find that the systems diverge, then we do analyze the code, but that saves us having to read every single line of code. We only focus wherever we find any discrepancy between the systems. We also want to make sure that we find errors before they go to the end-to-end testing. So the end-to-end testing is this process where quality assurance runs all these Sentinel samples. If they find that a problem with our pipeline, it may take like 1 or 2 weeks since the time we release that code for the testing and come back. By the time we get the results, we have no idea what we did 2 weeks ago. So we want to make sure that we find these divergences as soon as possible. So having this testing environment has helped us. The other thing is how we were wondering how are we going to tackle this problem. We look at the pipelines like this is a mess. It's very big. There are too many things going on. So sitting down and deciding to split it and take this, okay, we advance a little bit, has kept us moving. Like we feel that we have progress, even if we are about to finish. And right now we feel like we are really close to meet the first deadlines, but at the beginning it was very daunting. But having these ideas of sub workflows and subsections, and okay, this week we are testing this, makes it keeps the morale up, and it keeps the focus on something instead of panicking because you don't see the light at the end of the tunnel. The other thing is that it's very important to have a test data set that you understand that you can run locally, especially in genomics with the size of the data sets. Waiting for things to run, it's not fun, and it can also be a little bit demoralizing. So having this tiny data set has helped us a lot to keep the rhythm of the development. And the last thing is how we were really concerned of how to make sure that the old and new systems work the same. So having these databases and file systems in a fresh state each time we run the system has been extremely helpful, because we don't need to worry, which is the ID of the ticket that was generated. We don't care. It's always one. So as final remarks, I'd like to remind you all the things we cover today. First, we had a big migration to do, and we have to decide several migration strategies. Some of them included rewriting everything from the scratch, but given our organizational necessities, we decided to just lift and shift. So we changed as little as possible on each iteration. We also talk about the refactoring strategy that it's happening in parallel of the migration. Some of these changes were necessary to move to Nextflow, and some of them will happen after we have we have depreciated the current orchestrator and we're fully on Nextflow. We also talk about the validation approaches that we have, and how we simulate a testing environment that it's very similar to our production system, but in a smaller scale. And we talk about the lessons that we learned. Finally, I want to thank you for your attention. And all these people has been involved in our project. This is not just the three of us. It's a large project. And if we have any questions, we are here to answer them. Thank you very much.
Thank you. That represents a phenomenal amount of work, and I want to thank you really for sharing both the thinking that went into the thought process to develop this approach, and also the lessons you've learned so far. I've witnessed I had front row seats to the major sequencing center migrating its pipelines, and it can be a fairly daunting experience. It's really a phenomenal amount of work. So I think this will be a very valuable resource to the community. I believe a lot of people will be watching with great interest as you proceed and continue to go forward, and hopefully, I think a lot of people are hoping you will share the outcome 6 months or a year from now. I don't know what the time frame is, but you've got a lot of people anxiously waiting to hear from you. There were a couple of questions about validation, which Ricardo answered during his part of the talk. A lot of questions came early. A few additional things. Oh, yes. One, do you find a lot of divergences, or is the lift and shift strategy successfully keeping this to a minimum so far?
So, yeah, so we haven't found many big divergences on the modules themselves. We find some on the orchestrator side. So because the workflows were tightly integrated with the orchestrator, sometimes we realize that some of the behavior that was happening on the orchestrator, we have to move it to the component themselves or to the component wrapper. That's where we mostly found divergences. Not that much on the modules, but we still need to make sure that things are consistent.
One question about in the process of revisiting the code, have you found any bugs with the original approach?
Yes. So yeah, the short answer is yes. Probably Błażej has a lot of fun with that.
I had a lot of fun with finding bugs in Bertha, but yeah, this project also helped us to make our product even better.
And I guess one more thing, you've explained kind of the key factors that informed your decision to go with this approach. If you were thinking strictly from the point of view of accreditation, do you think it would be harder or easier to get accreditation with just a completely new code base as opposed to this approach?
Yeah, so I'm not an accreditation expert, so I'll answer to the best of my ability. But yeah, I can maybe ask our experts at Genomics England for a full answer. But I think from what I know, accreditation is based a lot on the usage of the pipeline. So when you're writing something from the ground up, because it's written on, like if it's completely new code, you basically need to create completely new documents describing what the code does, and then get that audited essentially. And I guess in our case, because a lot of the algorithms that do a lot of the bioinformatics analysis will remain the same, the auditing requirement is believed to be lower overall. Okay. So that's how we this approach has helped us in that regard as well. But that bit of the work is still outstanding as well, so this might change once we have a chat with our auditors.
Fair. Mm-hmm. Well, good luck. Thank you very much, and we'll look forward to hearing from you on how it goes.
Awesome.
Thank you so much.
Thanks, everyone.